Alright, so let's welcome Chiedozie.
Hey everyone.
Hi.
Can you all hear me? At the back end? Okay. My name is Chiedozie. Please remove to. Yeah. I think for the next, I was told I have 1 hour. I'm kidding. I have 25 minutes, but I'll make it 20. So I have 3 fun facts about me. For the next 5 minutes, I want it to be kind of interactive. So I want you to tell me which is the weirdest fun fact. First one, I used to have gray hair. I don't have gray hair anymore.
What happened?
Story for nobody. Second, I used to be very extroverted as a child, so much that I was suspended in GS2 for noise making. And then I became so introverted in university that I was stuttering when I would ask questions to the lecturer. That's fun fact number 2. That's life. Fun fact number 3. Oh, I watch movies, but I don't watch them to escape. I don't watch them to have fun. I watch them to criticize. So I pay attention to directing and acting and screenplay and soundtrack and all of these things. Which is the weirdest?
The last one.
The last one, yeah? The middle one. Oh, the switch. Extrovert to introvert. Anyway, so what I put there was that I used to have gray hair. That's story for another day. Anyway, if you have a child or a nephew who has gray hair or a niece who has gray hair, don't scrape all the hair down to the roots. That's just so that you don't lose it, because when you cut your hair all the way down, it doesn't go back. Fun fact. Anyway, so I used to, well, I still do. On one face, I write short stories and poems and stage plays, and I love doing that. When I most come alive is when I see my writing or stage play being performed by people, and when I see the reaction of the audience. Like if I write something and it was emotional for me and I wanted to cry when I write it, if I see someone in the audience cry, that's when I most come alive, because it's like the baby is being born. On the other side of me, I started off as a data analyst, and I have worked with Jumia, Andela, Brooklyn Data, and now Montreal Analytics. And in that span of my work and career, I dabbled into analytics engineering, went deep into BI as well, business intelligence. And these are just like 3 things I liked so much I had to get certified in them. So Looker, DBT, Python. That's the most I would say about me. So before I start, I want to speak on her question about DBT. DBT is data build tool. Pretty much my whole conversation, next slide, is talking about moving from data analytics to analytics engineering. Analytics engineering, I'll break it down and tell you what it is, right? When DBT came up, I started using DBT in 2019. When DBT came up, I think Andela was the first, about one of the first companies that adopted DBT. And we built a DBT pipeline, and then we were used as case study by DBT. Then it was not DBT Labs, that was when the company wasn't called DBT Labs. It was called Fishtown Analytics. And so we were used as a case study for Fishtown Analytics then. We didn't do the best work. DBT was still figuring out some stuff. Andela was still figuring out some stuff regarding their data. But we knew exactly what we wanted to use DBT for, and it worked. Like Chisom said, it was to slow down, query runtime. It worked. So what DBT does is before a couple years ago, the way you would build a data pipeline, you first extract it, then transform the data before loading the data, called ETL. When things, cloud computing and SQL first BI tools came about, you started seeing a change in that dynamic to say, we're extracting the data first, we load it into a data warehouse or some cloud computing platform, and then we transform the data. So ELT came about. And so with ELT, the transformation part of ELT was supposed to be, it was usually handled by data scientists, sometimes data analysts, sometimes data engineers. But analytics engineering came in as a kind of like a solution to say, data engineer, focus on your integration. Data analyst, focus on your reporting and your forecasting. while we focus on transformation. So when you have an example, you have Jumia, right? Jumia is an e-commerce platform. I love e-commerce, is the best example. Now, if you have Jumia as an e-commerce platform and you have, say, orders, customers, your vendor website, your service, your delivery guys, your logistics guys, all those apps and all those websites, you bring them into a data warehouse. And then your CEO says, I want to see XYZ data. The transformation part of it, joining customers to orders, to returns, to refunds, to have one single data pipeline, to understand your data holistically, that transformation process is done by analytics engineers. Does that make sense?
Yeah.
Cool, let's move. So, I'm going to ask for two people, a data engineer and a data analyst. Are there any, you're a data engineer? Awesome. Data analyst. So if I were a company and maybe I'm the CEO of the company and I say I want to see my retention rates for 2020 to 2022. Like I want to see the customers who signed on and then how many months did they stay before they did not sign on it. I mean before they, didn't order anything again. How would you approach that question from a data engineering perspective?
Thanks. First of all, I would ask where is the data? Is he, are we going to serving the data off an API from a third-party software? Is it already existing in our data warehouse? Or am I supposed to build a pipeline to push the data from wherever it is into our data warehouse? Then I would ask, okay, how frequently do you want to see it? So I can, schedule my pipeline runs and all. What rates do you want to see at? What are the case scenario where a company wants to see how much we have per hour? So, and the data wasn't hosted by us, it was hosted on MongoDB somewhere else. So we had to write pipeline to push the data out and stuff and frequently do some transformations actually before it gets handed over to the data analyst who does his own and all. Thank you.
He went to school.
Okay, so yes.
From a data analytics perspective.
Okay, so first thing is, where is data coming from? We have like in-house DB where to query after that is done. There's transformation, cleaning. So actually they do the cleaning because it depends on how messy the data is.
I love
so let's just say I get a clean data, I just basically transform and then so there are two ways to go about it. Do I want to analyze on Excel or do I want to move into Power BI to do all the analytics and then visualize? But the first thing I'll be looking at is doing a month-on-month client engagement to see, okay, who did what, when, and how did they actually do those things? Look at the numbers. Are we looking at them? Are we checking their growth rate? Are we seeing that, okay, they've not spent much or their wallet share keeps dropping? Are we saying that they are so wallet share saying that they are consistency? Those are the things I'll basically just take into consideration, then present my facts in a bit.
Thank you. I think the master, please give a round of applause. All right, can you guys still hear me?
Yes.
Cool. So they said something. It started from one question: where does the data live? Right? That's what both of them started from. But they're asking it in two different ways. And by the way, they went to school. I love that. So they're asking it in two different ways. He's asking the question for where does the data live in terms of data warehouse and storage? Where does the data live in terms of where is it coming from? How are you bringing it in? He's asking from the point of where does the data live in terms of how do I then transform the data to analyze it and give you what you want? It's only me that hear different. But that's how you guys thought about it, right? So the thing is, he then said something was like, oh, we clean up the data. Oh no, that's you guys. So that whole confusion of like who is doing what, when are they doing what? That is where the analytics engineer comes in to say, hey, you focus on your reporting and your forecasting and all the things that you want to do with visualization and charts and graphs. Data engineer, you focus on your ingestion and you're pulling in the data and all of that and all your maybe Python code or Fivetran or Stitch or whatever you use to ingest the data and everything. And I focus on transformation, right? That's the whole point of analytics engineering. Does that answer your question?
Yes.
Awesome. All right, so this is pretty much a chart showing this is integration, orchestration, CI/CD, everything. This is data analytics and all that. So the extreme part of it is like data security. That's what the data engineer is focused on. Accuracy, integration, cloud computing, CI/CD architecture. Data analyst is focused on impact analysis, life cycle, all that and all that. So if I were back to me being the CEO, hello, if I were to say I want to see my data and I want to see like retention rates from 2020 to 2022, he's going to be thinking about, oh, how do I slice this based on events? Like now some people, oh, maybe he notices something in the data about some people churning during December. Like maybe a lot of people churning during December, and you know there's a peak of people signing up in June. He will now think about it. Is there a promo that was running in June versus December? Or is it a seasonal thing? Maybe winter is making people just to stay indoors and not do anything. Or maybe summer is like, oh, I have to get my summer body, so they're going to buy gym equipment and all those things. So he has to now think about the data like that. Data engineer is not even concerned about any of that. Do you get it? Next slide, please. So this is the topic. And then, please, next slide. Josie Hall, she's a program manager, or she was a program manager from Google. I don't know if she's still there, but she said something, described data analytics engineering in a way that I resonate with. Data engineers build the cupboard. This is the entire data pipeline when it comes to cupboard and organizing stuff. Data engineers build a cupboard. They gather together the wood and the tools and put it together. The analytics engineers open the cupboard and start putting in plates, mugs, and bowls, and arranges them in a certain order. This could be arranged into particular colors or shapes or sizes. Now the data analyst will go to that cupboard, they know where everything is, and they'll now start pulling out things nicely. So they can grab the small blue mug. They know exactly where to pick the small, they know where to pick the blue, they know where to pick a mug, and then they go and make a cup of tea for the person who wants to drink it. This is a really good analogy for a data pipeline. So for data engineers in Brooklyn Data, that's why, I don't know if you probably in one of the Brooklyn Data meetups that we used to organize, you would notice or you will remember that we're talking about data engineers, analytics engineers, and data analysts as your three people who can actually give you what you want. You probably don't need a data scientist if you have those three guys, right? Depending on the company you're working with. If you're in a product company, then you probably need a product analyst. If you're someone that needs, artificial intelligence or machine learning, that's a separate issue. But for your regular cloud computing and reporting, those three guys, once you have them, that's it. So that's the what and how of data pipeline, analytics engineering, and all of that. Remember when I said the why and the when? When we started having cloud-based data warehouses, when we started having like SQL first BI tools, that was when analytics engineering came in. Of course, easier integration and extraction. When things like Fivetran and Stitch started coming up, it was like, oh, we really don't need a lot of data engineers if you can use Fivetran to pull this in. Not saying that data engineers' jobs are at risk, but like a company can decide to say, you know what, I don't want to use a lot of Python heavy code for integration. I just want to create connectors within Fivetran and then pull that in, into the data warehouse. And then I do all the transformation and then I, ingest it into Looker or Tableau or Metabase or whatever. Why move from data analytics to data engineering? This is pretty much my biography. I moved from data analytics and now I'm a senior analytics engineer in Montreal Analytics. Why did I do that? First thing, the ability to work on end-to-end data solutions. I was just, not that I was tired, but I was curious enough to actually want to expand, right? I used to just be like forecasting and reporting and dashboard building and BI and data development. So I would do health checks on people's Looker instance and tell them, fam, you're spending $20,000 on Looker every month, you need to stop that. That was like when I was doing full data analytics and analytics consulting, that was some of the things that I would do. And I was curious enough to say, hey, I only know one thing, which is data analytics. How do I want to expand? So that was what prompted me to do analytics engineering. Now, I don't know a lot about data engineers. Doesn't mean I'm not good at my job, but I just don't know a lot about data engineering, right? Now, I can work on end-to-end data solutions. Like I mentioned, I can use Python, I can use Stitch. I don't really need to do all the Python heavy code. I can do that, but not my preference. Do you understand? So I can create I don't support being a one-man team or a one-man data person. But I can literally go into a company and see, okay, what exactly is where does your data live? I can create a whole pipeline for you guys. That doesn't make me Superman anyway. So the second thing is increase opportunities for career growth. If I want to climb up the ladder, at some point, I can choose to be a data analyst. But there are certain things that I will not be able to do or know if I'm, say, managing a whole team of data engineers, analytics engineers, and data analysts, right? So for me to be able to climb up the ladder, I needed to get this right. Expand technical expertise, of course. When I started thinking about analytics engineering, I started thinking holistically about what analytics engineers could do regarding your entire pipeline. So I wasn't just focused on DBT and Looker. I was focused on what CI/CD looks like, or what integration looks like, or what blue-green deployment looks like. That's where I started thinking regarding analytics engineering. Greater control over data infrastructure, of course. This goes without saying. Higher earning potential. I don't know if I mentioned I'm from Navy, Anambra State. This is priority for me. So when money is involved, I want to plug my head in there. Please, next slide. What do data analysts bring to the analytics engineering world? Now, there are things that as a data analyst you already have and you already know, right? When you're coming into the analytics engineering world, it is important to bring some tools from your arsenal as a data analyst. What are those tools? First of all, attention to detail. This is something you probably spend most of your time building as a data analyst. If anyone, as a data analyst, they'll probably tell you, if you have a manager or like a director or somebody you're reporting to, as a junior data analyst, the priority they want you to do is pay attention to detail. If they're not grading you on it, you don't have a good manager. But they're supposed to grade you on attention to detail, in the sense that if you build a chart, if you build a graph, why is this number shorter than this number? Go back and check, like all those things. Just pay attention to your data. This thing is very important in analytics engineering. I previously mentioned something about transformation and talked about like how you need to understand your data, and you need to know probably know your business KPI. Maybe you shouldn't, but maybe you might not necessarily know your business KPI. But the thing is, know exactly what the stakeholder wants to use the data for. That's the primary thing. Attention to detail is key. Collaboration and communication, of course, you can't just do it alone. You need like collaboration from data engineer to know exactly where things are. You need collaboration from your stakeholders to know how they want to see things. You need collaboration from your data analyst. All these guys, you need to communicate and communicate properly. Hence, documentation. If somebody is going to come and write code after I finish writing the code, they don't need to start from scratch to figure shit out, right? Documentation is important, communication is important. Whether it is like physical, verbal communication, or it is like documentation you leave behind, it is very important. Problem solving, this is very important. As someone who is, doing the transformation is not the only thing you're doing as an analytics engineer, right? Right now, let me give you an example. Right now at work, there's a use case. I'm working as a consultant for a client who wanted to carry two DBT cloud projects, as well as 2 Snowflake instances. They wanted their whole data pipeline to be in those 2 DBT cloud projects and 2 Snowflake instances. This is how they wanted it. You have a DBT cloud project. The 2 DBT cloud projects, the reason they wanted to separate it was because of security reasons. There was supposed to be reporting on one, and there was supposed to be data on their revenue. So the data on the revenue, they will come and they needed audits, like auditors will come and audit their revenue stream, whether it's income or reimbursement or disbursement, or however they wanted to monitor their revenue data. Now, they didn't want anything in one DBT cloud repo to affect another. When I mean DBT cloud repo, I mean a company. You know how we say a company should just have maybe 1 DBT account for all their reporting and everything? This company wanted 2. Just because they want someone to come and say, I'm auditing this. But they don't want people, and a lot of developers work on the reporting side. So they don't want any work that the developer is working on to affect or cause breaking changes in the second one. So security is tight on the second one. Problem is, they wanted those two repos to start out in something they call the Snowflake production, which is two different Snowflake instances. It's not bad, it's not good, it's not enough that they want only one and two DBT accounts, they still want two Snowflake instances. So they said they have the Snowflake production and then they have the Snowflake dev, right? And so now they want to get the source tables and then feed it into Snowflake dev, do all the transformation, do all the processes, all the breaking changes, everything, push back to Snowflake production as production data. In my mind, I'm like, okay, I understand the whole point of having two separate DBT repo, right? But why two separate Snowflake instances? Problem solving. That's like something you akonuje. So when you have that like instinct to say, okay, what are the things that could cause me problem in the future? Let me start now to figure that out, right? The use case of passing two DB2 projects into two Snowflake instances didn't make sense to me. If it's that you wanted one DB2 project to be on one Snowflake instance, another DB2 project to be on another Snowflake instance, that makes more sense. It means that we're doing security, role-based access on your Snowflake instance, and all of that is happening there. But when you're passing both of them, it didn't make sense to me. So what I did was to say, hey, now, instead of doing that, I had to create a whole presentation to convince the client that they only need one Snowflake instance, and we can keep the two DBT repos on that one Snowflake instance. And then to solve their whole problem of, oh, is it going to be secure enough and everything, I was like, okay, let's do this. Let's build role-based access controls. Let's put things in separate warehouses, so at least the production data lives on a separate warehouse and is not affected by any run happening in development, right? So in a Snowflake instance, you can have multiple warehouses in one instance, right? So when one warehouse is working and doing development, it's not affecting the other warehouse. So the production data can run smoothly and doesn't have to waste time when they're doing development. So all these things are things that I had to think about with my team, solving problem for the future. We're not done with the migration project though, but we have already solved that big problem, so that when we get to that bridge, we can cross it with legs. Analytical skills. Of course, this requires you to do transformation, it requires you to do a lot of coding and all of that. You need to think analytically. One thing I've always said is data analysts are not coders. Data analysts are thinkers, analytical thinkers. When you want to grade yourself as a good data analyst, it's not how well your SQL code is. It's how good you're able to give a customer, a stakeholder, what they asked for. So if they ask for X, Y, Z, you can tell them, hey, you ask for X, Y, Z, why, ask all the questions. Why, when, where, which, what, who, how. And then you give them, you deduce that, oh, you want X, Y, but you really don't want Z. So how about I give you X, Y, and give you ABC, because you would need ABC. That's data analytics. Technical skills, of course, you need to have your technical skills. Next slide, please. How to move from data analytics to analytics engineering? Question of the day. I think this is probably, after this, maybe I'll stop. Maybe I'll keep going for the next 1 hour. So, gather experience with transformation tools like DBT. That's number one, right? DBT doesn't only just help you transform your data, it helps you build data in a modular way. In a way that you're bringing source layer as your base, you're building on top of that source layer. So if, back to my example with Jumia, right? You have customers, orders, returns, refunds, vendor, logistics, all those things, reimbursements, products, variants of products, all those tables are living as base tables. Then you now join products and variants together as an intermediate table. Join order and order items together as an intermediate table. Just things like that. And then at the end of the day, you're building your customers and your orders. If you want to see products that fulfill a particular requirement, you're building a dim product table or a facts orders table or something that's your final table that will be used by your final stakeholder. So understand tools like that and why they're important. And every stage of that modularity, you're testing the data. So in your sourcing, you're testing if the ID is unique, all of that. In your final, you're testing if the logic that you finally built for the stakeholder makes sense. Gain knowledge in data analysis, engineering, and architecture. Please do. Even if it's not like the technical expertise of pulling in data, just gain the experience. What is orchestration? What is DevOps? How do you think about CI/CD? Just understand those concepts of data engineering and you'll be good. And architecture, of course, building a code in a good structure. Learn more programming languages. Some people use Excel and Google Sheets and they're data analysts. I'm not fighting that. You are a brilliant data analyst. That's how I learned. I used Excel and Google Sheets back in Jumia. And I was killer Excel, Google Sheets dashboard. I was a data analyst in my own right. But at the end of the day, I needed more programming languages. I needed SQL, I needed Python, I needed certain things. Do you get? So learn more is going to help you. Understand cloud computing. This thing I talked about with my clients about moving from warehouses to another and understanding like scaling in warehouses and how to increase your warehouse size so you get low query runtime. Your queries don't run for hours. Understand how cloud computes data. Understand how cloud stores data. Understand what copying is and when you copy or you share, and if it's, if when you do a zero copy clone, for example in Snowflake, why do you do that? Just so that you don't want to. Zero copy means you're not taking more space in the warehouse, but your data is existing in another space. Do you get? So understand all of that because it costs more to store data. I believe you said something about window functions, and we were talking about, why should we avoid window functions? Why should we avoid? And he talked about it, said because it's costly to do window functions. So why do you need to simplify your code in a way that wouldn't be so expensive and cost your stakeholders money? That's something you need to understand. Network with analytics engineering professionals. I will provide links. I don't know if everyone is getting the slides afterwards. I should stop dropping. So I don't know if everyone is getting the slide afterwards, but please network with a lot of analytics engineering professionals. And then have a good grip on data modeling. That's your cocoa. That's the crux of the job. That's your bread and pap. That's like the base of everything. It's like, what makes me a good data analytics engineer is I understand modeling. Not just modeling as by bringing tables together, but I understand how to write a clean code, a readable code, how to document, how to build a code from scratch, how to build base tables and build them up to final marked models. I need to understand every bit about modeling. I need to understand how to model without just casually using distinct. And just because I want to do a quick stamp and fix on the code, I'll use it because maybe the code is duplicated. I'll put a distinct to make it one line. No, think about it. But think about it, like, why is my code duplicated? Why should I use these things? What other scenarios could happen that will make this code not duplicated? Can I use qualify function in Snowflake instead to just pick the most true value instead of just doing a distinct? Like, think about that in terms of data modeling, and then you're good. I think that's all for me. So look at the Slack channels. If this link is going to be shared, all these are links as well to those channels. So if you could not join DBT Slack earlier, just click on this link. It's going to direct you to where the DBT Slack is. These are all channels. If you get the slides, please click on the links and it's going to direct you to those Slack channels. DBT Slack, of course, is by DBT. Local Optimistic is shared by some people from DBT Labs as well, with people who I used to work with, that Chisom works with now, Brooklyn Data. So the founder of Brooklyn Data company also co-founded Locally Optimistic. Operational Analytics Club, I joined it recently. They're very brilliant. They want people to come. Data Talks, I think I'm in Data Talks and not Open Data Science. I can't remember, but it's been long I joined one of these two. For Open Data Science, I don't think I'm there, but I found it online and someone recommended it. So please check out these Slack channels. They post jobs, they post, some things that they're working on, and they ask questions about tools, so you can learn even from people's questions. They post trainings, they post just different things so that you can see people and network. People, they get job from Slack, so
Yeah.
they sleep. I don't know how this is it. They play. So any questions? My full name, Chiedozie Egbuna, Newi.
Yeah, I have a question.
Yeah.
Should all data analysts aspire to be analytics engineers? That's one. Do you think that the lines between data analysts and analytics engineers are actually blurred? Do they actually, in some cases, do the same things?
Okay.
So those are the two questions.
That's a very good question. So should all data analysts aspire to be analytics engineers?
Analytics engineers, not data engineers.
Yeah, analytics engineers. So should all data analysts aspire to be analytics engineers? It depends on what your career goal is, right? It depends on what you're looking towards, like what you're chasing at the end of the day. Some people want to be data analysts and they don't want to be core data analysts, right? They want to be a financial analyst. They want to be a HR, like people analyst. They want to just work in, healthcare and just know analytics as a data analyst, right? I wouldn't say aspire to be an analytics engineer because the crux of your job is more HR than data analytics, is more finance than data analytics. So it depends on where you're going and how you see yourself in the future. But if you really want to do core data analytics, I would say maybe not aspire to be an analytics engineer, but just learn everything else beyond data analytics. It's going to really help you. It's going to help you understand how to be a better data analyst if you understand certain things that goes on back end. The second question was, please remind me.
The lines between.
Yes, so are the lines blurred? It depends on some companies. Oh. Some companies will pay you 200K to do everything. That's rubbish. If you want to, if you work in a really good company, right, there should be able to be that distinct division of labor to say this is a data engineer, he's doing something. This is a data analyst, they're doing something. These analysis engineers are doing what they're supposed to do. When it comes to blurring the lines, some people actually blur the lines and say, okay, I'm a data scientist, so I do all the coding, the Python, the SQL, and everything, and I still do the reporting. I would say for you to have some sanity, you can either do that and just call yourself an analytics engineer, but you will have some sanity. Focus on one thing, and just roll with it. Because at the end of the day, what shouldn't be happening that I see happen a lot is where a company employs you as a data analyst and expects you to do everything. That shouldn't happen. Stand up for your rights. Any other questions? Yes.
I'm kind of interested in the scenario you used, right? Where you have
The warehouses and the repos. Yeah.
So, for facts, I double as data engineer and analytics engineer. So, like,
That's why.
Okay, keep going.
so, like, all the engineers like on my team, like,
Yeah.
we do analytics engineering. Like, we sometimes construct like matrices and transformation. So, we recently moved all our transformations from the code to DBT so that we can have everything,
Nice.
transformations just running on DBT.
One up for the BT.
Yeah. So we're having one problem now, right? And I've been thinking of the scenarios in my head, and you just mentioned this where we have problems with production, and we are trying to test transformations of pipelines, and we are pushing directly into like our production data warehouse, right? No, it's not bad, right? We are that good, like it's version control, so before you can actually merge to production, everybody takes a look on the team, whether it's logical, makes sense, and cost effective.
So what's the problem?
But the problem now is so that we have like one instance running. Let me not use instance, like one data warehouse running. I want to understand why you guys did it, because right now we're actually preaching to like have like a dev overall data warehouse, which in my head is going to cost a lot. Like when I mean a lot, then we have like a production instance of our data warehouse, because actually send data back into the apps.
Okay, I'm going to ask a couple of questions. Oh, that's a brilliant one. I'm going to ask a couple of questions. First of all, what is your size of data? Is it very voluminous? Is it very big?
Yes, transactions that run into like almost
trillions
every day.
Yeah, every day.
We average millions actually.
Millions. Okay. Similar to the project I'm working on. So what I'll say is, first off, know why you're doing an instance. I don't think you need a second Snowflake instance.